Okay, I think we will begin. We are recording this session so that for those of that couldn't make it, we will post this on YouTube and we will send out a link once it's been edited and uploaded. Everybody has been muted. If you have any questions, well, during my short presentation, please put it in chat. I will go through and answer questions once I finish my short presentation. Like I said before, it's good to see some familiar names and some new ones. My name is Steve Medwin. I'm the University Ambassador for the University Research Program. I've been in, those of you that don't know me, I've been in industrial research and development for my entire career. And the last 20 years or so, I've been in material handling. So it's really exciting to see this program evolve over the last few years. I recently retired and my sole part-time gig is supporting this program. So with that, we will get started. Again, if you're just joining, please hold your questions until the end. If you think of something during my short presentation, just put the question in the chat window and we'll go through afterwards. And then if there are questions that you have that I didn't get a chance to discuss, feel free to get in touch with me and we can have a one-on-one session at a later date. So this is our mission statement, if you will. This is on our website and it really explains what the URP is all about. The industry has evolved over the last 10 or 20 years, and there's now more of a end-to-end approach to supporting customers. Rather than just, in quotes, making wheels and steel, as we call it, making trucks, we're now working on information technology, automation, and energy storage, lots of other fields that really come into a complete material handling solution. So what we want to do with this program is engage with professors and researchers so that you can apply what you know and what you're passionate about to problems in the industry and publish the results, share the results with the industry so that everybody can move forward with new technology. And here's a great quote from our president, Mike Field. "We believe new technology and innovative approaches from academia's brightest and most innovative minds can inspire the supply chain of the future." So we're very excited to be in our 5th cycle. So what's new this year? Well, for those of you that had been following us before, we survived the pandemic. We're back. The teams that we had funded, we gave extensions to so they could finish their projects once they got back in the lab. So we're back, and some of the things we've changed. We have new themes, and we'll go through those later on. This time we've added some examples of specific projects that we thought of within the theme. We've taken some feedback that we got from you, and we have an optional one-page concept review stage. So we'll go into what exactly we're looking for there, but we want to make sure that the final applications that you submit are targeted to things that we're interested in. We'd like to focus on technology readiness level and how your proposal fits within this scale. And I'll explain a little bit more about that later if you haven't heard of the TRL scale. And we are funding still 12 months, but we're running the program every other year instead of every year. And this will give us time to do a little more planning up front, as well as communicate the results from the cycle at the end. What's the same? Funding levels are the same, so we're looking to fund multiple projects up to $500,000 per project. Like I said, the length of the project is 12 months. That remains the same. So it's a tight effort, but we think 12 months is a good period to accomplish some tasks. Again, each project will be assigned a liaison from the Raymond Corporation. In addition, I will be following the program. We will coordinate reporting and communication back to headquarters. As I mentioned, we are continuing to encourage you to publish the results, both as theses, if that's appropriate, or in journals. And we have the same website. If you haven't visited it, universityresearchprogram.com, and we have all the updated information on there. This is our 5th funding cycle. I think we're up to 6 years because we lost a year due to the pandemic. But every year we refine and improve the process. So we're excited about this cycle. In the past, we've funded 12 projects from 16 different universities. So it really has gotten to be a widespread effort. And if you're interested in who we funded in the past, here's the link that you could follow. The average amount is a little under $300,000, and the total funding has been over $3 million since we started. Over 20 journal papers have been published, and actually, the most recent one is by a team that is still in process. So out of the gate, they thought they should work on a survey paper, and it has been accepted and published. So that was very exciting. Another way to get exposure is through your university marketing or media group. And an example of a recent story was this one that Cornell put out. Great video, great story, and we're excited about this project as well. It's still underway. So here are the themes that we're proposing this year. There are 3 groups, and you won't be surprised that the first one is material handling in an uncertain future, code word for a pandemic. We're not anticipating, hopefully, another pandemic, but in the past, my understanding is to make a supply chain robust, businesses were focused on regional disruptions, and they were prepared. If there was a hurricane in Florida or flooding in Texas, there were ways that they had prepared to handle that. Certainly, they didn't prepare for a global pandemic. So if you have thoughts or ways to go at that, I found it interesting to follow first-person stories about how different companies handled their material handling over the last year. The next one is material handling in a smart city. And a smart city is basically a industrial 4.0 effort related to an urban center, where you have sensors and distributed computing really focused in a planned way for a city. And I know Toyota is working on something called the Woven City in Japan. And here the example would be what equipment and distribution facilities might fit or needed to support such an effort. And in terms of distribution facilities, here's an idea for warehouse design. This is really an omni-channel. And this grew out of some of the efforts that retail stores did, where you would order online and pick up in person. And I think there's an acronym for that, BOPIS, something like that, where it seems like if once customers try that, they really like it, and the thought is that that's going to continue in the future. And what's the best way for a warehouse to be designed to manage that? Whether it's start out as a retail storefront and they added a back office with a small warehouse, or if it's a warehouse that adds retail with reverse logistics, and what would it look like? What kind of equipment might be optimized for that kind of facility? And the last one in this group is urban and suburban package delivery. So this could be last mile. How do is that automated? I know there's some things on the market related to that. Another thought is there a way to configure goods just before delivery? I don't know if I'm thinking of a 3D printer on a UPS van, but is there something along those lines? So we're looking for ideas that are maybe more pragmatic. We'll get to a little bit more of that in the TRL discussion, but these are the first group. The second group is improving material handling, and obviously automation is at the top of the list here, and again reflecting trends recently where again with concern about COVID and transmission, there was a lot of push to automate. What can we automate? But one of the downsides is it's a big leap for lots of companies. So the question is, are there hardware and software that could be developed that could ease this transition? Is there perhaps a way to standardize an automation package so it's not customized for each application? Something along those lines might fall in that category. In the news, I heard this morning that Boston Dynamics was purchased by Hyundai. And I know Boston Dynamics has done some work recently. I think they have a whole automation and warehousing division. So it'll be interesting to see how their products evolve when they're owned by an automotive company now. So again, all these, for all these categories, please check out what's out there. What's commercial, what's been shown publicly, what's been published. Make sure that we're on the cutting edge here. Advanced sensors for material handling. I know there's lots of sensors that are coming into automotive use for operator assist. There's ultrasonic sensors, there's cameras. Because they're used on automotive, the cost is going way down. And that's very important for material handling, where this industrial application is very cost sensitive. So what new technology is out there that can be used for indoor location tracking, measuring wear, monitoring ergonomics? So what's happening? What do you know about it? Or are you developing a sensor that maybe could be applied here? Advanced vision systems. So with the lower cost vision systems for cars, cameras, and with higher performing computers, is there a new balance? Is there a new equation that could significantly improve productivity? If we had, 10x the computing capability on a computer chip for what's available today, what would that do? How could that improve productivity? Just things to think about. The last category, industrial design. We're still designing vehicles. Material handling is still making forklift trucks. Are there new materials, composites perhaps, that can improve the design or manufacturability or sustainability? One of the things we get asked every so often is recyclability of forklift trucks. And when they're made mostly out of steel, then they are recyclable. But if you have some thoughts about industrial design, we're looking to fund them this cycle. Operator ergonomics, a lot of effort is around digital twins. Can you model operators? Can you model workers in a factory? And how can you use these models to determine ergonomics and human factors? And how could that improve productivity? And this one's a little farther out, but if you look at some of the future studies that are out there, and I mentioned, I've got a link to MHI, which has talked about this before. Is there a neurotechnology application that would make sense? Could you improve operator productivity if you had a direct connection to the operator's brain? Now, I'm not sure operators would do this. I'm not sure who would, but is this something that would make an operator significantly more productive? Or is there something like a haptic connection where if your watch vibrates, let's say if something's approaching from behind from a blind spot. So there are different types of neurotechnology connections. But the focus here probably should be on a productivity improvement, whether it's an invasive or not. So that's a little out there, but there's discussion around this in the industry. So we want to see what you think. Okay, I mentioned that we're looking at receiving a one-page concept paper. And this came out of discussions I had with a number of you who applied last time during our feedback discussion. So we're looking for an interim review period. And now this is optional. We recommend it, but again, it's an optional. Basically, if you could send us and either the email on the website or my email, a summary, just a one-page executive summary. What are you thinking? Pictures, graphs are also good. And I have some more details later. We're not looking for a budget up front or any kind of approval. Just, hey, this is where my thoughts are. What do you think? And we've already started reviewing these, and we promise to get feedback within 30 days, and we'll do this on a rolling basis. The deadline is August 27th to receive these. And I have a more detailed example. This is one of the projects that we did fund and is being funded this current cycle. It's on the website if you want to look through. But basically, these are the sections. You could pick your own, but it's we want to know a gist of the project. If you've done experiments before, or if this is a brand new idea, any data that you've already collected. This will give us a really good idea. If it's aligned with our themes, then it'll be easy feedback. If you want to go outside the box and make a proposal that's not one of the themes we've had, you're welcome to submit. And this is perhaps a good way to do it because it's not, there's no downside. There's no restriction on the number of these you could send in, whether it's you personally or the university. We might regret that, but right now we don't have any limit. Like I said, we'll do a rolling review in 30 days. Please don't wait until the last day. No schedule or budget. Again, it's still a 12-month effort is what we're looking for. Feedback will be focused on alignment with the themes and Raymond interests. So if you elect to go outside the themes, if it's still something that is interesting to the reviewers, there's we'll let you know. Don't be insulted if you take a chance and we say, well, maybe we think you should pivot. I guess it's one way to get a dialogue going. Ultimately, we want focused, good applications, good proposals, and this is one way to work on getting feedback. Another way is to set up a discussion with me and we can talk. We won't use any comments as part of the final evaluation, the evaluation of the final proposal. And if you do incorporate changes, it's still not a guarantee that you'll be selected for funding. So we still go through our normal process. Okay, I mentioned technology readiness level. Some of you probably have heard of this. It's been around for a while. I believe NASA started this, it probably at least 20 years ago. Basically, and here are a couple links to read up on it. Wikipedia has a really good introduction to it. There's some good illustrations here, and this is from that article. And you can see here there are 9 stages, and they're broken up by basic technology research, gradually demonstrations to different stages, pilot scale, and commercialization. And I like this illustration because it shows where you are in academia and where I'm coming from in industry, and how this effort is an attempt to bridge that with some collaboration. We recognize that going from developing the raw knowledge to a business product takes a lot of effort. So what we're looking for is projects where you've already done TRL 1 and 2, you've done basic work, and we will fund going to TRL 3 to 4, where there's demonstration in the lab. If there's, a simulation or a modeling that you're doing, that the closer you get to hardware, the better. We like to see things operational lab. If your field doesn't lend itself to that, then can you simulate it? How can you take it to the next step from just a really good idea? So that's what we're after. And it'd be really good to include your assessment within your application. Okay, you're at TRL 2, you've done some work in the lab. It's not prototype scale, but this is what we would do to go progress down there. Now, just to sort of take a step back, let's say there's a successful project that we fund, and we want to, outside of URP, take it farther down towards commercialization. This is another framework to talk about it. And we recognize that there would need to be additional effort on our part, working with you, to develop the technology further. So my mind, this would involve another program that would be funded to make this bridge to develop the technology to the point where it's operational in a customer site, let's say. No guarantees, but that's just my vision of how this would apply to successful programs. Again, questions about this we could talk about at the end or in a one-on-one. Okay, so this is really as close as I could come to explaining what's needed to prepare a successful application. I mentioned MHI earlier, material handling industry. They have a lot of material online, and some of the ideas for themes are in their report. I reviewed their reports, and they're very forward thinking. It might be worth you downloading those and looking them over. But they also have a lot of basic information if you're not familiar with material handling. If you're not, that's okay. I think one of the goals of this program is to bring new academic thinking to material handling. So if you're not familiar with it, here's a textbook that you can download that talks about warehouse science. It's been out for a few years now. It's free download. Again, if you're new to the material handling, something to check out. I highly suggest visiting a local warehouse. Seems like anytime there's two highways that intersect, whether it's in a city or just outside of a city, there's got to be a warehouse. I know Amazon is all over the place and they give tours. So one way, and I know they were doing virtual tours through the pandemic. They might be doing in-person tours again, but here's a link if you want to check that out. But there's lots of different approaches to get a tour, but it would really be good to see firsthand what's happening in a warehouse. It's amazing. You never think about what happens when you have a million different products stored in a warehouse that's maybe not a million different products, but a million square feet with hundreds of thousands of products. It's just amazing. Understand what's commercially available today. I mentioned Boston Dynamics as an example. They've shown robots that will pick cases from inside a rack, put it on a pallet. Is it commercial? Not yet, but they've shown it. What can you build on, or what could you improve if that's the field, the area that you're interested in? Lots of papers. We funded a few, I guess it was last year, drone delivery of medicine. And there's a lot of literature out today, and that's evolving rapidly from a commercial point of view also. And this is probably the biggest one. What's the innovative concept that uses your research, your expertise, your passion? And how can you apply that to real world, eventually real world material handling application? And we're looking, something a few years out, 2 to 5 years out. Now, I'm not sure we're going to have neural implants in 2 to 5 years, but that would push the envelope in terms of farther out. But we want to take what you're interested in and what your expertise is. Please use the TRL scale. What's the scope? How are you going to push the technology forward with this funding? And really encourage you to submit a one-page concept paper like we talked about, and use the feedback. That's the whole reason we're doing this. So that's my formal presentation. Here is my email if you would like to contact me outside of this. I don't think I see any questions in the chat. That can't be. I can't have explained things so well that there are no questions. Here's the website, and as I mentioned before, it's updated with the new themes and all the new materials. So if you don't want to type a question, you can unmute yourself and ask. Like I mentioned, we will post this video on YouTube at some point, so you could go back and catch all the URLs that I showed if you didn't get a chance to write them down. Okay, question from Jennifer Pazur. Can you give some examples of what you envision as potential deliverables? A working example in your lab, let's say it's an automation project, not full size, it wouldn't have to be full size material handling vehicles. It could be scaled robotics, going through an exercise that you would videotape along with data that you collect. So a working prototype in your lab would be ideal, with what the results, what does it show, as well as what you would need to do to take it the next few steps. Anybody else have any questions? That was good. Thank you for presentation. Would it be appropriate to have a meeting for narrowing down ideas before sending in the one-page proposal? Absolutely. I've done that already this cycle. It's open-ended. Again, there's no guarantees, but it's in the interest of good proposal. It's interest in optimizing everybody's time. If we have a discussion that we say, hey, we're thinking about this. This is the research we're doing. How would that fit in? And we can do a little bit of brainstorming, but yeah, absolutely. So shoot me an email and we can work out some timing. But again, if you want to do a couple one-page proposals, that's fine as well. It's up to you. The intent is to get a dialogue going, to have discussions to make, ideally we'd want to have everybody have a really tough decision making where everybody has spot on proposals that we'd love to fund. So that was a good question. Okay. Well, another question. Nope. Would there be any budget restrictions to equipment? We're giving you a certain amount of money to be spent on equipment, on graduate students, on your salary. That's up to you. Any equipment that's part of the proposal would be yours at the end. So that's part of the decision making. I mean, if you put in the maximum amount and all of it goes to a piece of equipment, I mean, there's nothing that says you can't do that. Here's another question related to deliverables. Is there a scope that you're looking for, that is full large-scale solutions or smaller self-contained projects pieces? That's a really good question. So let me take a stab at that. I think the ideal program would have a vision that's large scale, but given that this is only 12-month period, you want to break off a piece that you can do, that you can accomplish, that could get to some kind of demonstration in the lab. We want you to be successful. So we want you to accomplish what you say you're going to do it. And solving world hunger is hard to do in 12 months. But if you're going to create a new seed that would go on the way, would be a step in solving world hunger, that would be good. So present a piece, but in the context of a large project. Hopefully that helps. Would the proposals be first come, first reviewed, or be all reviewed after the deadline? The one-page proposals will be reviewed on a first come, first served basis. We have a deadline of November 4th or 5th. That's on the web page. And they were just going to review the final proposals all at once. Here's another question: improving productivity of MHI worker. If that's the theme that I pick, then the potential deliverable would be to show that was accomplished in a test site. Right, and sometimes doing experiments in a live warehouse might be tough. So you could get a grad student or an undergrad to do a mock-up of the motions, let's say. And we've funded that in the past where there was a lab set up with motion capture cameras. And I know they hired undergrads to be the worker bees and to be monitored. So if you look on the TRL scale, they differentiate between a test in a lab versus a test at a customer site. So I think the customer site would be down the road. Okay, I'm starting to lose my voice. So if there aren't any other questions, it's been great. I appreciate the questions you had. I appreciate your attention. Let me know if you have any questions, if you want to have a one-on-one discussion with your team, or if you just want to start the process with submitting a one-pager, that's great too. Thank you, and I think we'll end at this point. Take care.